Good day everyone. Today, I'll be discussing the continental margins and deep ocean features. Now, let's begin with continental margins, or the underwater transition zones. Continental margins are essentially the underwater edges of continents. They represent the transition from the continental crust to the oceanic crust. Think of them as the submerged borders where the land meets the deep sea. There are three main sections to a continental margin, each with distinct characteristics. First, we have continental shelf. This is the shallow, gently sloping area closest to the shore. It is actually the most biologically productive part of the ocean, teeming with marine life. Next, continental slope. Marking a steep descent, the continental slope is where the seafloor drops off more rapidly. Submarine canyons, carved by underwater currents and sediment flows, often dissect this zone. And next, continental rise. At the base of the continental slope, you will find the continental rise, a gentle accumulation of sediments that have been transported down the slope. This area transitions into the deep ocean floor. Continental margins are broadly classified into two types, the active and passive. The distinction lies in their tectonic setting. Active continental margins. These margins are located at convergent or transform plate boundaries. This means they are areas where tectonic plates are colliding or sliding past each other. Due to the active tectonics, the continental shelf is often quite narrow. The continental slope is generally steep, often leading into deep sea trenches. A prominent feature of active margins is the presence of oceanic trenches, which are the deepest parts of the ocean. They form where one tectonic plate is forced beneath another, or the subduction. Active margins are prone to frequent earthquakes and volcanic activity due to the ongoing tectonic movements. For example, is the Pacific Ring of Fire. Passive continental margins. Passive margins are found at divergent plate boundaries or within the interior of tectonic plates. They are far from active plate boundaries. Because they are not tectonically active, passive margins typically have a broad, gently sloping continental shelf. The continental slope is more gradual compared to active margins. Passive margins transition into the abyssal plain, a flat, deep ocean floor. These margins experience relatively little earthquake or volcanic activity. For example, is the Atlantic Ocean margins. Now, let's move on into the deep ocean features. First, we have submarine canyons. Submarine canyons are deep, steep-sided valleys carved into the continental slope and sometimes extending onto the continental shelf. They are essentially underwater versions of canyons you might see on land. These canyons are primarily formed by erosion, mainly through the action of turbidity currents. Imagine underwater avalanche of sediment-rich water rushing down the slope. These currents have tremendous erosive power, gradually carving out the canyons over time. Submarine canyons act as major conduits for transporting sediments from the continental shelf to the deep ocean. They often serve as hotspots for marine life, attracting a diverse range of species due to upwelling currents and nutrient availability. Next, turbidity currents. As mentioned, turbidity currents are underwater landslides or sediment-laden water. They are denser than the surrounding water due to the high concentration of sediment. Intense storms can stir up sediments on the continental shelf, initiating a turbidity current. Seismic activity can also trigger these currents by destabilizing sediment accumulations on the slope. As a turbidity current slows down and loses energy, it deposits sediments in characteristic pattern called graded bedding. The coarsest sediments settle first, followed by progressively finer material. Over time, turbidity currents play a significant role in shaping the deep sea floor by redistributing sediments and creating new geological features. Next, abyssal plains. Abyssal plains are flat, featureless expanses of the deep ocean floor. They are among the flattest places on Earth. These plains are formed by the gradual accumulation of sediments, primarily fine-grained clay and silt, that have settled from above over millions of years. Despite their seemingly barren nature, abyssal plains provide a habitat for a variety of specialized deep-sea organisms, including bacteria, worms, and other invertebrates. Next, ocean trenches. Ocean trenches are the deepest parts of the ocean, characterized by the extreme depths and steep V-shaped profiles. Trenches are formed at subduction zones where one tectonic plate is forced beneath another. The bending of the subducting plate creates the trench. They are typically located at active continental margins. Ocean trenches are often the sites of major earthquakes and tsunamis, as the movement and rupture of the plates generates seismic waves and displace large volume of water. Next, volcanic peaks or the seamounts and guyouts. These are underwater volcanoes. If they rise above sea level, they form volcanic islands. Some seamounts have a flat top due to erosion by waves when they were at sea level. These flat top seamounts are called guyouts. Seamounts and guyouts are known to attract fish and support rich ecosystems. They provide a hard substrate for organisms to attach to, creating diverse habitats. Next, mid-ocean ridges. Mid-ocean ridges are underwater mountain chains that run along the ocean floor. They are formed at divergent plate boundaries through a process called seafloor spreading. Magma rises from the mantle, cools, and solidifies, creating new oceanic crust. Mid-ocean ridges are the birthplaces of new oceanic crust. They play a vital role in plate tectonics and the Earth's geological processes. Lastly, hydrothermal vents. Hydrothermal vents are fissures in the seafloor where heated water and minerals are released. They form where seawater meets magma beneath the ocean floor. The water is heated for extremely high temperatures and becomes enriched with dissolved minerals. They are commonly found along mid-ocean ridges. Hydrothermal vents support unique ecosystems that thrive in the absence of sunlight. These ecosystems are powered by chemosynthesis, where bacteria use chemical energy to produce food. In summary, we explored continental margins, the active, passive types, and diverse deep ocean features like canyons, plains, trenches, volcanic peaks, ridges, and hydrothermal vents. These shape our planet's geology and support unique ecosystems, highlighting the ocean's dynamic role. So, that would be all. Thank you for listening.